Hello students, so in this video we're going to be looking at applications of various functions. Same sort of thing as our previous video. Just going to glance at some problems here. For instance, this is what your homework is going to look like. Number 1 says Brian is driving on a highway. He uses 1 gallon of gas for every 40 miles. The distance d in miles he travels on g gallons of gas is given by this function. So we've got some sort of function given to us. How far does Brian drive if he uses 5 gallons of gas? Alright, well, let you think about how to plug in 5 into that function there, okay? So if we just sort of scan through here, we can see there's a series of functions, some situations where we're going to have to plug in the value. However, on some of these, I'm just going to warn you, instead of giving you the independent quantity right here, some of these are going to give you the dependent quantity, which will be over here. We'll just show you how you would set that up here in a few minutes. Alright, also there's going to be some analysis on those equations, and then we're going to get to some problems where there's going to be a word problem, there's going to be a function that's given, and then we're going to ask you what are the limitations and what are the descriptions of the domain and range. For instance, what does the domain look like, or what is it actually referring to if in this equation, and then what are the values? Are they all the real numbers between this range, or is it a set of discrete numbers that go on forever or maybe have an ending point? So, and the same thing with the range. So those are sort of questions that we're going to be looking at. Also, just a few more advanced functions that are going to have some trig functions, the sine, cosine, tangent, inside the function definition, and then plugging in some values, and we'll go over a little bit of how to apply that and how to solve that both forwards and backwards here in a moment. Alright, so let's talk about applications of various functions. So the first thing you need to do is you need to know what the input is and what the output is. Know what variable depends on what. For example, let's say you've got some sort of verbal description, maybe the car salesman pay, or maybe his monthly pay is it's based on some salary. He gets some fixed amount per month, and on top of that he gets a commission. Maybe it's a set amount per car. So if we look at a function rule, that maybe it would say P of C equals 500 plus 750C. So 500 is that base pay. He gets $500 no matter what every month, but then he gets $750 per car. So the two types of questions that you're going to have in this section is, what is his pay if he sells 20 cars? So something very straightforward. It's saying, what is the dependent variable when you have a given independent variable value? So for instance, when C is equal to 20, and the way that we would take care of that, you just plug in 20 for C, so 750 or 500 plus 750 times 20. Run out of room here, run into the scroll bar on my page there. So you go down there and eventually you get a number. The other type of question that you're going to come across is something like this: how many cars does he have to sell to make, say, $3,000 in a given month? Maybe that's how much he needs for his rent, his insurance, all this stuff like that. Pay for his food. And so in this case, we would say P of C, the amount of pay that he gets in a given month for a given number of cars, is equal to $3,000. So you just leave that 3,000 over there and you substitute in the function rule here on the left hand side, and then solve for C. So subtract 500 both sides, and you end up with C is equal to number. So it's important to recognize that these two questions are asking different things, and they're asking you to find different things. This one is asking, all right, given a number of cars, what's the amount of pay? This one says, given an amount of pay, how many cars would he have to get? And so just understand what, like I said, what's the input, what's the output, what's the dependent variable, what's the independent variable. Independent variables actually be here. Dependent variable is the output. And I'm sure you'll do great. This is somewhat similar to one of the problems that you'll have. Alright. And then, as you saw a few minutes ago, you're going to have to deal with the domain and the range of real-world problems. So we'll just continue this car salesman example. So anytime you have y as a function of x, well, in this case you would say p as a function of c. P depends on c. So the domain is, as always, possible x values. In this case, that would be c values. That's number of cars, so the number of cars that he would sell in a given month. So we could say, all right, well, that means c is greater than or equal to 0, and you've got to have whole numbers. He could sell 0 cars or 1 car or 2 cars. It just really doesn't make sense logically for him to sell half of a car. I guess maybe if you worked at a parts store. Anyway, maybe a junkyard. But no junkyards here. So what you need to do in these problems with the domain range, think about the limitations. So not only the upper bound and the lower bound. Obviously he couldn't sell negative cars. Could he sell, 100 cars, 200 cars? Yes, there's no real limit at this point on the number of cars. But also the type of numbers, whole numbers, fractions, things like that. That's what you need to think about when it comes to the domain. So when it comes to the range, so that would be possible p-values, that's his pay. You could say, all right, one way that you could think about the range of p-values is you'd say, okay, what's throwing in some of these values, perhaps maybe starting with the lower bound, what pay values would you get? So if he sold 0 car, 1 car, 2 car, 3 car, you might say, well, the pay could be all reals. Well, not really, because if the domain is limited to c greater than or equal to 0, then he's going to get, if he even sells 0 cars, you're still going to get $500. So there's no way, as far as contractually, that this car salesman would make less than $500 in a given month. He's not going to make, there's never going to be a situation in which he would make $400 or $450 or $200. He's always going to be $500. So the range of values starts at $500. And you can say, all right, it's all real numbers, $500 going up. Well, once again, not necessarily. There's no way he could make $501 or $502 because he has to sell a whole number of cars. So 500 plus 750 times 1, so he's either going to make 500 or he could make 1250 or so on and so forth, each time going up by $750. So with respect to the range, plug in some of those values from the domain, particularly like the lower bound to kind of, and also maybe the upper bound. Think about the types of numbers that you would get, whole numbers, fractions, positives, negatives. Is there anything that just doesn't make sense? All right. Quick reminder on trig functions. You probably don't need it, but I'm going to cover it anyway. Anytime that you have maybe a function and you've got a trig function, if I give you the independent value, so b of t is 4 sine of pi t. I say find b when t is 10. Okay, great. Plug in 10. No problem. Calculator can handle that. The other type of question that you would have is find the time when, say, b is equal to 2. So you say, okay, 2 is equal to 4 sine pi of t. That's what b is, so it's going to be equal to that formula. And once again, we are going to solve this. Isolate the trig function, so in this case we'd have 1/2 equals sine pi t. If you recall, the way you get rid of a sine, cosine, or tangent is with the inverse. So one way you can do this, I don't know if we explicitly said this, is you could take the inverse sine of both sides, inverse sine of 1/2, and the inverse sine of the sine of pi over t. And the inverse sine of the sine of pi over t are just inverse operations. They cancel each other out. So we have over here inverse sine of 1/2 is equal to pi t. You can plug that into your formula, then divide both sides by pi, and end up with a nice answer for t. Alright, so those are the sort of problems that you're going to be working on in this section. Good luck, and I'll see you in class.